Hi, my name is Yerger, and I'm doing my presentation on drilling advances in geology, how we can improve drilling. What is drilling? Drilling is the process of creating boreholes with heavy machinery that are used to collect resources and information about the earth. So this is an example of how a borehole is dug and how drilling is used. So this is a well drill. So a drill will be set up here. These are different layers that you can access, and then this whole thing is the borehole. So boreholes can be dug up to a few meters to several kilometers deep, depending on what you're trying to dig for and the reason you're digging. But why is drilling important? So drilling is important because we get key resources from it, like oil, natural gas, minerals, and groundwater. Those are all things we need to live and necessities we use throughout our daily lives. Drilling is also important for scientific research, environmental studies, access to underground data, resource exploration, and geological dating. We can access all the water tables and geothermal energy, all those different rocks, and we can date them. It basically helps us understand the earth, the rocks, how it got there, and how it moves. Next is construction and engineering. Before building something, the underground rock and soil levels need to be checked for stability. So don't forget where those materials come from to build either, because a lot of the concrete scaffolding and all that other stuff to build buildings, they come from rocks and minerals and metals that are dug from the earth. Environmental monitoring. It allows us to see and monitor groundwater to detect pollutants and monitor groundwater quality. Groundwater is very important because it's used to all throughout all our sewer systems and into water treatment plants, which then go to drinking water. So keeping that water safe from pollutants and monitoring it will help us thrive and keep the ecosystem clean. Those are only a few examples, by the way. There's also more core samples you can get from it. There's geothermal energy you can dig in, which is a more clean way to use energy. This is why improvements are needed for drills. We need to improve efficiency so we can cut through materials and reduce the maintenance costs for the drills. Improved efficiency will help us dig deeper and faster, so it can help us get more research and more minerals and materials. We can also improve the safety on drills. Some safety drills can have features like automation, so you don't need people constantly working on the drills so people can get hurt. You can have some automated features to keep people safe in a way. You can also improve them for environmental impact. Improving drills so they're more precise at where they dig can help not disturb environments and keep them clean. We can improve the depth and range on them so we can access deeper into the earth for more research and studies, also to get more materials that are deeper and out of range of conventional drilling. So this would be the budget for what I'm proposing. The drill repair costs, just for the repairs alone for the drill, would cost between $400 and $1,500, depending on how big the repair is. Also, plasma bit drill is a drill that I will go into later in the presentation. It's a company I found that specializes in high-tech drills. But if I were using their drill, it would be 1,000 meters per dug, $1,000 per meter dug. And for conventional drilling, which is what is the standard practice of drilling, it is $3,500 per meter dug. To build the actual drills, it would cost between $100,000 and $1 million, depending on what drill you're trying to build and how deep you want to go. It also depends on how many drills you are building for the practice you're doing. And then the drill bits, which are what dig and grind up the rock on the tip of the drill, those can cost between $10,000 and $50,000. There's also different drill bits that are diamond tipped to increase efficiency and dig deeper, like the PDC drill bit. That would cost between $50,000 and $100,000, again, depending on how many drills you have and the type of drill bit. So what is Plasma Bit? Plasma Bit is a big part of my project because they are a company that makes drills that are significantly better than the standard drilling today. They use plasma energy to dig instead of drilling and rotating the hammering drill bits. So conventional drills, like this advanced conventional, they have these drill bits which grind up the rock and then spray water in to make it mud to dig deeper. That's only good up to a certain depth, like 2 to 3 kilometers here. I have a table right here. But Plasma Bit actually uses plasma to melt the rock so they can dig deeper, more efficient. And they say that the cost is a lot less depending on how deep you dig for conventional drills. So it would save money and help increase the depth while saving more money. Alternatively, you can use a hybrid solution because plasma bit's good deep down. Drilling through the soft rocks and the sediments, you want to use conventional drilling. So if you can get a hybrid, you can go up to 10 kilometers, and you can also get through the soil, the soft rocks, and the sediments very easily. So in conclusion, drilling plays a big role in a lot of our lives without us even realizing it, including the groundwater, the materials we use, all that sort of thing. Drilling is important for gathering resources, scientific research, construction, and the environment. Drills are not perfect, however. They could use upgrades and better technology to increase safety, increase effectiveness, and help out the environment by staying cleaner. So having access to more advanced drills can help boost our knowledge of the earth, gather valuable resources, and move toward a greener energy approach.